Yeah, be recorded. Got it. I have to say yes. Okay, good morning, everybody. As you will see, I'm going to present some of the latest research and also some of the interdisciplinary work that I do, and explain why it's so interdisciplinary, really. As you know, I'm at the Montfort University, where I'm a professor in AI, and I also lead an institute which is interdisciplinary between media and computer science. But I am an honorary lecturer here at UCL and also an honorary professor in the civil and geomatic engineering, as well as this is where we are now. So why am I, turn up the volume, okay. Okay, yeah, I did. So what am I presenting? I'm presenting the work that I do in affective science. Why study affective science and what is it? You can approach it from different aspect, which could be a more psychological or social psychology to see the interaction through people. But because of my background in computer science, I'm more interested in emotion recognition that can be done by machine, or emotion generation from a machine, let's say, put it simply. But I've done also some more research into the psychology of emotion, which I include, and usually this kind of publication more in psychology journal rather than computer science. So why do we need affective science? This is because we tend to build machines that interacts with human, and if the machine could, or you know, well, these days is the AI, but let's say any system that is able to interact with people could understand emotion and interact with in an emotional manner, then this would be much more accepted, because we, you know, we build things like robot dog and this kind of idea that need to become real. They need to have this social intelligence. But more recently, we have a lot of application, including self-driving car and so on, that need to study the human that is driving in order to see whether or not is alerted, whether or not is responsive to take over and so on. And there are a lot of applications in smart homes and smart technology, from the support to elderly, to recognition and diagnosis for mental health and other conditions. So there is a lot of application of this kind of research, not only building machines that recognize and interact in a manner that is similar to human, and therefore the work of emotion. So this is a very much interdisciplinary research. I'm usually publishing in computer science or psychology. However, you can see, you will see that it is very interdisciplinary, because according to the application and the aspect that you are highlighting, there might be different other discipline involved. So the main point is I have built a wealth of knowledge to apply qualitative and quantitative approaches, and data science, which now then help, you know, with the help of machine learning, it's become much easier. So I build artifacts and then evaluate them using different approaches. And I'll give you a panoramic of different research. They use different methods. I picked three. If you have time, I will explain a bit more. So the concept is that in order for a computer to process emotion, we need to operationalize it into something that can be measured. And one of the easiest things to think about emotion is to consider as positive or negative, whether it's pleasant or unpleasant. So whether there is an arousal or a calmness in the person. And therefore you can think about an activation or deactivation, and pleasant and unpleasant, and different emotion will be mapped into this wheel according to these coordinates. So this is the more extensive wheel of emotion. There are different versions of this. Geneva was one of the first that was presented, but there are different versions, and in particular, they have divided a quadrant in 8 pies, and then they are able also to map the different kind of emotions more or less into this diagram. This means that we are able to have coordinates and then kind of assess what emotion is being felt by mapping them into this to this space. Yeah. So this is one of the first application when the emotional wheel came out. And I will present now one of the first sort of applications or research, which is the color morph. And this is been done by collaboration with a student, a PhD student at the Art School of Design in Edinburgh. They came with me with this artifact, and she wanted to evaluate it. And then we ended up doing another artifact and doing much better version, in my view. So the original artifact was this. There are tubes which change the shape of the textile according to the type of stroke that the user gives to the textile. So they are inflatable tubes just covered into a textile that is able to expand. And then there is some kind of intelligence or an algorithm that is able to recognize the different stroke. So from this, we started thinking about what kind of emotion, what kind of sensory experience, and start to put a conceptual framework that would look at the design, the aesthetic expression, the shape-changing movement, and how this could be perceived by the sensory person, and what could we use this for. And then we came to this other prototype, what I'll show you now. And basically, it is a similar idea, but in this case, there is also light, touch, and different shapes. And the light that you see in the center, the ball in the center, is emulates the heart rate of the user while the user is using the coral morph. And also the idea was to create an artifact that is able to induce kind of mindfulness or relax people. And this kind of research was done during COVID. So it was very much something that we said, yeah, we need to do something to help people calm down. So these were the kind of conceptual idea. And as you can see, this is the coral morph. That the name was given later, you will see from the qualitative description that the people have made of it. So it has a sense of breathing. So it's like he's a pulsing, and the color changes from violet to yellow to red to be more intense if the person gets agitated. It has still inflatable tube that also are much more, I've got much bigger movements. So they look like tentacles, and response to touch input, but also to the heart rate measured by, on the interface user. So first of all, it is not the most, I mean, it's quite interesting, but we had to collect the heart rate, so we had to connect the people to it. But it's quite an interesting idea overall. I mean, could be done better, wireless, whatever, but we managed to do this one. So this was built by Hin Yi in University of Edinburgh, and this is part of Edinburgh College of Art. She built this as part of her PhD, but this publication, we did it outside the PhD in order to publish some of the artistic work that she had done. So these are some examples, and basically what we're trying to do is to create the illusion of social intelligence so that the coral morph is able to respond to the user in a way that is congruent. And we use some of the social psychology where people mimic each other during social interaction. And if they do so, they are perceived to be more friendly, they are perceived to be more in tune. So we mimic physically, but also emotionally and so on. And so the emotional mimicking was what we tried to do with the heart rate and the movement and so on. So that the kind of inflatable movement would correspond to the kind of stroke also that they receive. So it is an organic shape and it has this kind of soft movement, and it looked like an animated organism that people consider to be a coral. Yeah. So we evaluated this to see whether it was able to induce mindfulness by basically calm, positive affect, which is in the bottom right part of the quadrant, whether the participants were willing to sustain the tactile interaction, so continue to play with it, and for how long and what did they think of it. And then we also evaluated the robot for his social intelligence. So we, whether it was animated or perceived natural, interesting, appealing, and so on. We also consider whether it could be that some people might have been skewed towards the use of this. So people's subjective ability could have been different. So for example, mindfulness. So people that do mindfulness activity might be more prone to become mindful through it, and maybe people that didn't not, or age or whatever. So we also look at people characteristics. So this was an art installation that was put in an entrance of a building that was all white on a stand, and people were invited to come and see it. It was one at a time, it was during COVID, so it was all done in a sterile and one at a time manner. We had about 55 participants, and it was done in China by the student while she was there, because there was nothing else we could do. And the people were between age 25 and 55, so all sorts of ages. And basically we tested these main elements. So the emotions induced by this motion and interaction, the perceived quality of the soft robot, the therapeutic or possibly therapeutic quality of mindfulness, and this idea of the key metaphor, which is the chi is like yoga or meditation or kind of state of suspension in which you are calm. We use several tools. I've got some results that I'll show you now, from the analyzing the facial expression to analyzing the heart rate variability to the questionnaire to the qualitative analysis. So these are some of the tools, including what is called the sum, which is a very quick way of representing graphically but also in a scale, what the people feel the arousal imbalance are. And this sum is connected with the wheel. So it's very easy to score this and then map this to the wheel of emotion in the sense of arousal imbalance. Yeah.
So do these different pictures there correspond to different emotions? I mean, how does
No, not emotion, is arousal imbalance.
Okay,
so basically, are you more aroused or calm? Is a positive or negative? Yeah, emotion. And then the other one is a lot or little. And because these things are kind of intuitive, the picture version of the scale is easier for people to score rather than say in an objective manner, rather than say a lot, how much? Okay, but does it look like that or does it look like that? So it's much easier. This is taken from other research, the sum I didn't invent it. And allow you is this self-assessment, non-verbal pictorial assessment technique. But also we use other standard psychology questionnaire like the trait meta mood scale, and also the mood introspection scale by Meyer, the social touch questionnaire to see the willingness of people to give or receive touch, good speed that allow you to measure the social intelligence of the robot and so on. So we use also battery of tests. And we use the emotion recognition. This is a software. There are many software. This was a software app that can be installed on the phone that was recording, and people were, so their video and their emotion were analyzed automatically by the AI. Is a standard tool. And they were mapping to the wheel. And you can see that the emotion were in the lower quadrant, right? Which means they are calm and positive. So that's the kind of effect we are looking for. And they were classified from, if I look at the lower quadrant, confident, hopeful, longing, attentive, contemplative. There is also a spike of activation. And if we look at the average heart rate across the participant, what we see is that when they start interacting with the robot and they touch it first, they're surprised. Therefore, it's like, ooh, activation, right? So it's like, ooh, these things moves. Oh, wow. And then after that surprise or that activation, then they count down and they realize, oh, this is cool. And they didn't want to stop unless you said, well, look, we have another person there. So it was quite pleasurable for them to do. So what we've seen is that the classification of the emotional recognition was in line with the average heart rate variability of the participants. Also, we ask on the qualitative analysis, what do you feel and what these things looks like? And what they said is that you look like a marine organism that is calm, elastic, and so that's why we called it a collar morph. It's a morph in shape. They also discuss the quality of the material. So they said it's nice and fluffy, but they also said that the material, because it was kind of a lace, so he had a bit of a texture. They said, oh, this should be like silky instead. You know, they made comment like that. So mostly they like it, but they said, oh, you should use a really smooth material instead of the lace, yeah, and fabric. They found that it was a positive tactile experience, so they wanted to touch it. They found it reassuring, like a, you know, like if you stroke a cat or a dog, this is your collar morph. And that they suggested some further improvement on the prototype, and whatever they did, there was a correlation with the heart beating, and they could see that the more they calmed, that they were able to change the effect on the coral morph, not only by touching, but also with their own reaction. So they perceived the mimicking of the robot, which was quite interesting.
So there was movement as well that reflected the heart beating?
Yes, so there were two things that affected the heart beating. So the inflation reflected the kind of touch that you did. So if it was sudden or slow, it would be the inflate, would mimic that. But the heartbeat in the center would pulse like an heartbeat and change color. In a way that it was congruent. So if your emotion was high, like arousal, then it would be more on the red spectrum. If you were calm, it was more on the violet-blue spectrum. So the way that we perceive the color in itself. So blue is calm, right? And red is excitement. So we moved through the spectrum. There was a lot of stats, okay, obviously, that I'm not going to present, but basically, having done the stats, we also seen that there was a difference between young and older people. Young people, of course, were happier, but the most interesting one is there was a correlation between people that do mindful activity and people that don't, and people that do mindful activity liked it much more because it's like they're more into probably this kind of things. So it was very, very interesting. She also produced other artifacts, which we didn't evaluate, but she has quite a lot of very interesting things. And one thing that I was very interested into is this kind of inflatable wearables, let's say, or clothes. Yeah, and the idea, I mean, she just built this as inflatable, but if we could put some intelligence in it and even meaningful interaction, then it would be quite interesting. But we didn't get to that because she, you know, is like she did the PhD and that's it, as usual. Okay, so I will explain another publication that we've done with, this was a second year student when we started here at UCLIC Psychology, that we did the project as a, in second year, they already do some like little project, and then we continue in the third year, and then we continue to his master to do this kind of research. And basically the idea was to study the phenomenon of autonomous sensory meridian response, which is induced from video. So this is a phenomenon on YouTube, and basically there are people that produce video that have a known effect of calming people, so that people put them on. And the video consists of different sound created by the artist and different kind of pictures. So there are satisfying pictures as well as simply people doing the sounds. So we specifically studied tapping because obviously each sound is different and each type of, SMMR trigger is different, but there are different kinds. So we had to concentrate on one at least, and we chose tapping. The reason we chose tapping, I'll show it in a minute, but basically the idea so far before this publication was the ASMR is something that makes people calm down. And that's why we were interested in the emotional elicitation, and that it was skewed, the perception of this phenomenon was skewed towards positive emotion. So the idea was, is it? So the question, the research question, is it possible to have different kind of emotional experience and still perceive this sensation? So what is ASMR? ASMR is basically is described as a tingling perception that comes at the base of the neck. It's like a kind of a shiver.
Okay,
Yeah, a tingling sensation that calms you down. But what we were trying is to make an alternative interpretation of what this is, and if it's possible, not only to elicit a positive emotion, but also negative emotion. So we consider three states, which is fearful, relaxing. So, in the activation, if you look at the wheel, activation, unactivation, or calm, and then neutral. So something that is neutral as a control. And we selected the video that these are relaxation video that had the top scores on the YouTube for at the time. And then basically they consist into the artist simply tapping on different material that make like a kind of a sound like this. Now, if you just listen to the noise, this could be interpreted differently. It could be rain, right? It could be someone knocking. It could be people walking, right? So it depends on the frequency and the way that the tapping is expressed. So what we did with research, fear video from YouTube again, that were sequence or taken from different scary movie. And we map the frequency to the kind of images that come from that. So we replaced the visual context, so the video, not the sound. And it was administered in a way that was first you see the video and then you hear the sound and then your interpretation comes in. So it was disassociated, including this control video, which was the simple ping, that game, like bum, bum, the ball, which has no, it's a ball moving around. That's your control, right? So there is no, it's like neutral. Let's read.
So the fear video, was that with sound or?
No. So
okay,
all the
sound.
video,
okay.
So all the video were shown as video, and then you had the tapping, and then we did all the measurements, right? And so it depends. What we found is obviously that you can see is that according to your emotional interpretation of what's happening, your reaction would be different. And the fact that you have ASMR is only an enhancement. So it only indicates that you have predisposition towards perception of sound, but it doesn't necessarily mean that ASMR is positive. So I will explain how we got to this. So first of all, we got 180 participants worldwide, and we divided into people which are SMR able and SMR incapable, or they don't experience ASMR. This is because it is a personal ability to perceive this kind of, so not everybody.
How did you identify people?
We asked.
Okay.
Yeah, so we screened them. Well,
Other
different
heart feeling.
people get
Okay.
it.
Yeah, some others feel feeling.
Yeah, and different sound
Yeah.
as well. So we were looking for tapping. So some people found this calming, right? And there is stroking, there are different sound. So different sound elicit different reaction, different people. So we were looking for ASMR able people. And especially if they responded to, so they were screened by a procedure at the beginning that would ask questions and show things and make a little test so that we could divide them into ASMR and non-ASMR. And we found, because we posted the experiment online on ASMR lists, you know, Reddit list and so on, we got many more ASMR able people, which is what we were looking for, but then we still had the control, right? And then we had the 3 condition, and we had, you know, about one third of participants divided into, you know, they went in one of the 3 conditions, which is looking at fear, looking at relaxation, like the YouTube video, or this ball moving around. And then they all experience the sound.
Okay.
That the sound was the same. It's not that we change anything, right? And so they were recruited mostly on Reddit or, you know, University College London volunteer list. They were all sorts of age, from 18 to 55, and they were from all over the world. We divided in 2 main groups. So 1/3 was about European, loads of Americans, and then other countries include Asia and so on. This phenomenon is born more in Asia. So it's quite interesting that we have also this population, but it seems like it doesn't make any difference. So it's not country specific, basically. But although, you know, we have 180, we don't have millions, but yeah. So the experiment was quite interesting. So we divided the people whether they were capable or not. We collected the demographic. We asked for the mood before they started the experiment, because that could have been changing the way they did the mood at the end. And then we gave either a relaxation priming or a fear priming or the control condition. So the priming is the video. Yeah. And then we gave the auditory trigger of the tapping. And then we gave the self-assessing mannequin that you've seen. And also we made a mannequin, which I'll show you now, that allow you to label the intensity of the ASMR sensation felt. And then they repeated these conditions, and then we did a post-experiment questionnaire, which collected the mood at the end of the experience. So they did one of the 3 conditions. So the group were, so they, for each group, they experienced 5 video. So the repeat was that you've seen 5 videos. So at the end, there was an amplification effect. But you either did fear or relaxation or the control, yeah? So this is the scale. We built a some-like scale of ASMR intensity, saying how big is your vibration, yeah? So that people could easily rate it. And then we made the assessment. And what we've seen is that having the ability to feel ASMR tapping in this case is more an amplification effect on your sensory experience. So you have a sensory amplification, you are more sensitive, physically sensitive to sound compared to people that were not. So it is not necessarily an positive emotional experience. It's only that the video that will get published are those positive, because people obviously want positive things. They don't want to be scared, but you could easily use it as they do.
To scare people more.
Yeah, to scare, as they do in famous film like The Jaw. That you feel the heartbeat, boom, 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 right? That was more scary than what you were watching, right? Yeah. And so we all know that, and we all experience that, and being sensitive to sound, it just amplifies the effect, right? So this is more like an increased ability to be aroused by sound, basically. That's how we looked at it. Okay, so that you can then increase any emotion and play on the fact that these people are sensitive to sound, tapping sound, in order to enhance their emotion, which is quite an interesting conception, because so far people were looking at this as oh, well, you know, it's like a positive, mindful experience. No, it's not. It's a sensitivity, it's a subjective sensitivity, which is quite a different way of considering ASMR than it was so far in the literature. So this paper was quite not controversial, but like interesting. Yeah, interesting. Okay, so then I come to, this is unpublished research. Yeah, if we can stop 1 minute. Research, this is something that has been done and published. What is the ASAD? Basically, emotion, assessment of pain. Pain is like negative feelings, yeah, is usually done with questionnaire. And people say, where does it hurt? And then they paint, or here, red, or they kind of like a body activation, and they put colors on it, and they tell you 1 to 7. The problem is that if I want to compare my pain with your pain, or my pain now against 3 days ago, we don't have an objective manner of assessing that, because we don't know what that green meant for you 3 days ago, and what does it mean? What is my green and what is your green? It's too complicated. We need a manner to, although it is a subjective feeling, but we need a manner to compare, at least within the same subject. So at least I can, so if I want to do it with a computer, basically, that's the point of everything here. If I have to put an AI to help you, I need to know, for rehabilitation or whatever it is, I need to know exactly, are you better or are you not? Is this helping you or is this not helping you, right? So we need a more assessive manner. So what Felipe here came up with is, why don't we use sound? So the sound can, the idea was that sound and the frequency of the sound can indicate pain, because, you know, the pitch sound is like, and the squeaky sound is more painful, right? It's like a kind of association that we automatically do with, without knowing exactly what it is. And so he constructed this ASAD, that's how we call it, assessment of pain, with a different sound. And people can play in the different note and then say, oh, the pain that I feel sounds like this. And it is an easier way of associating, you know, like the sound. You look at the picture, you say, yeah, the vibration is like this. Yes, my activation is like this. This is the same idea based on sound, because sound is better, like squeaky sound is definitely pain. Everybody associate that, right? So it's an easier way of association. Now we had the manner, okay, does it work? That's the usual question. And so what we did, we induced fatigue in the foot, and you will see why we did the foot. That's the continuation. And he made them wear heels, so do walk up and down, wearing heel or flat shoes. And then in the middle, you had to do this walk, then sit down and do this exercise, which are induce fatigue. So in your muscles, calf and feet. And then you had to walk again, and then it could then assess your pain level. Let's say discomfort is not really pain. We call it pain, but it's actually discomfort. And then, so it looked like this. This is one of the mapping of the fatigue, let's say, or the pain. But I mean, we didn't, because it's of ethics, we didn't really induce pain. We just induced fatigue, really. And then we look at the difference, whether where did the sound move to, and where, and according to which kind of people. And what we found is that between before and after, there was a 2-note change that was objectively different, significantly different. So wherever you started the sound from, if you were fatigued with that kind of exercise, you went 2 notes down. And also that according to your physical fitness and ability to wear high heel and low heel, that you would obviously start from a different sound and then in a different sound. And so people that were fitter, obviously they supported better the exercise, right? And so we did all this mapping of the sound, the stats, and so on. And basically the ASAD allows this objective comparison before and after. And so if we were now building an AI that would help you, then the AI would be able to say, okay, this is better and this is worse, because we have a manner of quantifying that. Yeah. Now, next, why did we do all this? Because Felipe wanted to build this smart material. So he came with the idea that if we can build, for example, some shoes or something that can help people balance or increase the comfort and so on, then we can put an AI that will change your shoes or your wheels, or depends if you're a machine or robot or a car or whatever, or an artificial muscles that would help you do whatever it is that you need to do. So he basically built, and now we're going into material science, physically built a composite that, or a material, it's not a composite, he used already existing materials, but that can be activated or deactivated and has different property, like a muscle, so they can be harder or softer according to the activation that you do. And then should you be able, so he had to spend the rest of his PhD trying to build this and prove that there is an activation, and that's what he's done. And now with this, you could connect this to an algorithm, the famous AI bit, that would then adapt to the people and increase their comfort, okay? So I can play some of the idea. So there are different activation. So say you use it in the heel, you could have a softer ear or an harder ear. And you can change the quality of the material, I mean, softer or harder. And this is the building of the material. Yeah.
Yeah. No, but then we had to change it because the
Yeah.
printer wasn't good enough. So we had to start making molds.
Yeah. And then build it manually. And also he built it in water to the bubbles. There were quite a lot of problems with the material. This is done with Gaetano Burreschi in material science. He's a bioengineer, because this is beyond me. I do the AI and the human, the psychology, but this is beyond me. But basically it's made a material that is activated by electricity. And then what he had to do, he had to test this material resistance to pressure or pulling like a muscles. And then that's what he has done. Yeah, that's what is. The rest of his PhD was about not only building, but building the best one that can do that. And so in the end now, he has built this material and we're looking for application, the kind of application that we can do. Initially, he thought about shoes. But you can do much more than that. You can put wheels, for example, in Formula One that adapt to the terrain, or you can build art, a cardiac things that, like an artificial muscle of the heart, or other kind of muscles replacement. So think about bionic people. And, now we need the application for it and evaluation. And so that's his work. I think we are nearly there. I spoke forever.
No, that's very
yeah. So this is now my current grant that I just wanted. It's very weird because, of course, I'm Professor AI. So now a lot of the research, interesting research now, is about the use of AI and whether we can have regulation that help us with this use of AI. So think about my emotion recognition. I mean, you can use it as all the science can be used in a bad way or in a good way. The point is that if we can put some regulation in, then people will build and test and evaluate things in a manner that help us and not goes against the human. And so one of the most kind of debated things is, since COVID is AstraZeneca and Pfizer, and how can we validate this medicine, these vaccines, these things that people take, and should we do the digital twins that can validate these things in a laboratory before we give it to the human, and so on. And so basically the work here is to build an ethical and regulated framework that look at the way that medicine and things are manufactured and put in the regulation, so that follows procedure, so that we can ensure, we can say that this is ethical and can be certified. So kind of put some regulation to say that if you've not done this, this and that, then you should not test it on human, for example. And part of this would be simulations, right? AI simulation of what could happen. And then since we can simulate a lot of the human as well, so why not? Okay, and this is the grant at the moment. I have a lot more research in this area, which I didn't put. And most of the things I'm interested is well-being, of course. And because I've got the tools to measure that, so I've got quite a research in this area. Another PhD student here at UCL did autonomous vehicle and people attention, or if they're distracted or not, and what happened in takeover request. So if the human needs to do that, and what do we need to do to alert it in a way that it responds quickly. Another research is about studying, I was quite interested by gaming and people that have gaming addiction. And this is a matter of well-being and trying to better understand gaming addiction. And one of the publications that I've done that is out already is to look at whether playing aggressive games increase your aggression. Okay, this is a debate that has been going forever. It's like the SMR forever, but this is even worse. And what we found is that if you play game from age 16 over, 16 plus, it does increase your verbal aggression. So we're not, so you are more verbally aggressive. Now, we are continuing this kind of research. I've got a PhD student at Montfort that was a UCL student that has come there. We're continuing this into more of a theory of well-being and the effect of online socialization on your well-being and your offline socialization. And that's it. That's my latest thing. So thank you very much for listening.
Thank you very much, Daniela.